Welcome to differentiation with the chain rule. So we're going to make sure that we use our reference sheet that is given to you for examinations. So on your reference sheet, you will see that the first formula under differentiation is y equals f of x to the power of n. So when some function is in brackets to the power of n, we're going to follow the derivative rule that's given. So dy dx is equal to n, so the current power goes down the front, and you multiply by the differential of what's inside the brackets. Then notice you rewrite your bracket, so you rewrite that function, and you lower your power by 1. So let me just clarify that again. You put the power down the front, so the n comes down the front. You times by the differential of the function, so whatever's inside the brackets, you times by that. And then you rewrite your bracket, so you rewrite the function, and you lower your power by 1. So these are the two examples we're going to look at. We're differentiating the first one, 2x plus 1 to the power of 5, and the second one, x cubed plus 2x all to the power of 4. So for the first one, so using the rule, you bring your power down the front. So our current power is 5, so we bring that down the front. We multiply by the differential of the function, so what's inside the brackets. So the differential of 2x plus 1 is 2. Then we rewrite our function, so our bracket, with a lower power of 1. So that 2x plus 1 now becomes to the power of 4. We tidy it up. 5 2s are 10, so 10 outside of 2x plus 1 to the 4. With our second one, following the formula or that's on the reference sheet, power down the front, so you bring the 4 down the front, times by the differential of the function, so what's inside the brackets. So if I differentiate x cubed plus 2x, I get 3x squared plus 2. Now that goes inside of brackets because that's one of the multiples. And then I rewrite the function with its power lowered by 1. So that's the x cubed plus 2x to the power of 3. Thank you.